Hi student, today we are going to look at another topic called infinite series. Okay, so on the previous lesson we talked about infinite sequence. Okay, but today we're going to look at series, infinite series. Okay, but to do this, let's recall our definition of infinite sequence. Okay, so a sequence or infinite sequence can be given as this notation. So n equals to 1 to infinity. So this is our sequence notation. Okay, we call it infinite sequence because if you look at this infinity term appears on the top limit here. Okay, now this series can be written as A1 when n is 1, A2, A3, A4 up to AN. Okay, so we already know that this is the first term, and then this is my second term, third term, fourth term, and this is my nth term. Okay, but then we gotta make sure that this is until infinity, so we don't know this n, the infinity term here, right? Now what is infinite series? This is sequence. Okay, this is called I just want to recall to you, this is called infinite sequence. Okay, but what is infinite series? So infinite series can be given as the notation is slightly different from what is given for the sequence. Okay, so let me just change my marker to blue if I can, or yellow or green. Okay, so let's say we have this notation here. N equals to 1 to infinity an. Because of the summation notation here, this is a summation notation, so my infinite series can be written as a1 plus the addition. You add the term. Okay, you add the term up to an and so on. So a series is the summation of the least of number or sequence. Okay, summation for the least of number or sequence. So this is what we call infinite series. The n is often called the index of summation. Okay, so pretty much sum an. This is the infinite series notation. You can also have the term called finite series. Okay, finite series, we'll look at that later on, but let's look at a few examples. Let's look at a few examples here. Okay, what it means for the infinite series. Okay, let's say evaluate. Given a question, evaluate summation n equals to 1 to 5n. Okay, now to solve this, so you just gotta find the series of this given sequence here. So I can write it n equals to 1 to 5, n when n is 1, 2, 3, 4, 5. Okay, when n is 1, n is 2, and you add them together up to 5, so you get 15. Okay, now look at another term here, another example here. I want you to evaluate summation n equals to 1 to 4 n to the power of n. Now to do this, similar to the one we did earlier on. So when n is 1, we have 1 to the power of 1 plus 2 to the power of 2 plus 3 to the power of 3 plus 4 to the power of 4. That's it. Because our n is 4, we stop at 4. Okay, now you can just use your calculator or anything you have to add this, okay? Or you can, I don't know. Okay, but it's not that difficult, okay? So we have 1 plus 4 plus 27. 4 to the power of 4 is 256. So the total here should be 288. Okay, that's it. This is how you evaluate a given infinite series. Okay. Now the question can also ask you to write a finite sum of a series. Finite sum of a series. Now what this term here mean? What it mean by finite sum of a series? Okay, so it want you to find the nth term, finite sum, the nth term for this series. So for example, let's say I have this series here, 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16 plus 1 over 32 plus 1 over 64 plus whatever the term. Okay, now look at this series here. Now why this is called a series? Because I have a addition term here. For every term, the first term, second term, you add them, right? Now adding this term can give you the cumulative sum. Okay, so let's look at what is the nth term here. So I can also write this as something like this: summation n equals to 1 to infinity 1 over. Okay, look at it's a power of 2, right? At your denominator, so it should be 2 to the power of n. Okay, 2 to the power of n. When n is 1, I have 1 over 2. When n is 2, 1 over 4. When n is 3, 2 to the power of 3 is 8. When n is 4, 2 to the power of 4 is 16. When n is 5, 2 to the power of 5 is 32. Now you get that. Okay, you get that. But what is the finite sum? So in order to find the finite sum, there's something else you need to know, which is called the partial sum. Partial sum. So meaning, what will be the last value here? What is the last value here? Okay, so we can see that when the term here, okay, 2 to the power of n. Alright, so what happened here? Let's draw a table to understand this series better. So I have my n term here. I want to change it to blue, but it seems like it's difficult. How can I change it? Okay, anything else? Not red. Okay, let's say like this: n, and let's look at sum of n terms. Okay, this is my n. This is my n. N is 1. Okay, and I have 0.5, which is half. This is for n equals to 1. This is n equals to 2. N equals to 3. I think you get that, right? Get that? Okay, now this is a sum of the terms. So when n is 2 here, what are the sum of the first and second term? This one. Half plus 1, 4. So 0.5 plus 0.25, which is 0.75. Now when n is 3 here, I mean I gotta add another one here. So I need to add 0.75 plus 1 over 8 in decimal. So you get 0.875. Now for n is 4, I'm going to add this term here. So 0.875 plus 1 over 16. So 0.9375. Now keep adding them when n is 5. So 0.9375 plus 1 over 32. So which is 0.96875. Now what happened here when I keep adding this term, let's say for n equals to 10, I've already done it before, so I'm just going to write it down the answer. You get 0.99902344. Now similarly, when I keep going on, let's say n is 15. I have 0.9999698. When I keep going on, let's say 25. I got 0.9999997. So what we can say here, the term when being added, the partial sum becomes closer to 1. So this term here, the answer is 1. So the general series has a sum. That's what you could say. So what this mean? So what does partial sum means? What is partial sum? So I gotta write it down so that you remember. So a partial sum. Okay, this is what it means by a partial sum. Partial sum. Is the sum is the I'll put an S no without an S. Partial sum is the sum of part of the sequence. Okay, and this sum of partial sum, the sum of partial sum is called finite series. Okay, so in other words, the partial sum of an infinite series is the sum of the finite series of a consecutive term beginning from the first term. So like what I've shown you before, if let's say this is an an term, this is the an, 1, 2, 3, 4, what I have, 5, 6, so on. This is the an. So my partial sum also denoted by Sn here, where the first term is first. Now you add with 2, 3. Now add with 3. What do you get? 4 plus, 1, 1 plus 2 plus 3, or 3 plus 3, which is 6. And 6 plus 4, which is 10. 10 plus 5 is 15. 15 plus 6 is 21. So this is this is what it means by partial sum. Okay, so this term here, I can denote it by this is my S1. My S2 is A1 plus A2, which is my S2. Okay, now I can have A1 plus A2 plus A3. So this one, right? A1, 2, 3. I got 6 here. So this is my S3. Now I can have, so obviously this is my S4 here, which is my A1 plus A2 plus A3 plus A4. And therefore, I can say in general, Sn equals to summation I equals to 1 to n ai. Okay, so this is my partial sum notation. Okay. Okay, so we know what is partial sum. We look at it on our on the previous video just now. Okay, now why this partial sum is important? So partial sum can is used to find the convergent and divergent of a series. So that's what we're going to look at today. Convergent and divergent of series. Okay, that's our series. So we know the definition of infinite series. So this is our infinite series. N equals to 1 to infinity. A n here refers to a1 plus a2 plus a3 plus so on. Now we know what is partial sum, right? So the partial sum is denoted by, I just gonna write it like that. Partial sum we have denoted as Sn. So this is infinite series. Okay, so partial sum Sn is given as Sn equals to summation I equals to 1 to n ai, where ai here is my a1, a2 plus an. Okay, so don't get confused between these two terms, because partial sum here means you're adding the first term and the second term, first term, second term, and the third term, and so on. Okay, now what we can say about the convergent, if the sequence, if we're going to call it the sequence here, if this partial sum series sequence is convergent, and the limit and approach infinity for this partial sum, there's a value here exists, a real number, then we call the finite series an. Okay, the infinite series an is also convergent. Okay, so in order to find the convergent and divergent of a series, so you need to find the partial sum. Okay, if the partial sum, the limit of the partial sum, you have a finite value exists, that means this series is convergent. Okay, this number S here is called the sum of the series. Okay, otherwise we call it divergent. Okay, so how to do this? Okay, let's look at one example. I think the similar example that I have shown you earlier on. Okay, so let's say we have given this infinite series n. Okay, so how to know? So determine whether the series is convergent or divergent. Okay, determine its sum, and then after you've determine its sum, so meaning once you know, in order to find whether it's convergent or divergent, you need to find the sum. Okay, so remember this is my an. Okay, this is a series of my an, right? This is my an. Right, now what is Sn? So we gotta find the partial sum. In order to find the series convergent or divergent, you need to find the partial sum. So the partial sum is written as I equals to 1 to n I. So from an infinite series, you're gonna find sum of a finite number, or the sum of the partial sum is called the finite series. So you're gonna up to n term here. Okay, so for this question here, I can actually do a table. Okay, let's say I'm doing a table here. Table never straight line, never a straight line. I don't know why. So let's try it properly. Okay, there you go. Okay, So what is this? This is my sequence an, and this is my partial Sn. So an here refers to whatever this n value here. So where n is 1, so I have 1, 2, 3, 4, 5, 6, and so on. Okay, now the partial sum here refers to the summation. Okay, the summation for Sn here. So if this is 1, this one will be 1 plus 2, 3. 1 plus 2 plus 3, 6. 1 plus 2 plus 3 plus 4, 10. 1 plus 2 plus 3 plus 4 plus 5, 15, and 21. This is my Sn. Okay, so now you know this is my this is the sequence for an. This is the partial sum that you obtain. Okay, you can see the difference. Okay, now what do you do here? Now, what is the formula for Sn? I mean, the formula for an is very easy, right? It's a summation. Okay, the summation for I equals to 1 to n. But what is the formula for Sn that can give you this thing here? So Sn is summation I equals to 1 to ni, which is this thing, 1 plus 2 plus 3 plus 4 plus 5. So, but where my series here is given as, my series for my Sn is given by 1. So my Sn in terms of sequence, 1, 3, 6, 10, 15, 21, okay, and so on. Okay, so how can you write this? So Sn can be written as the partial sum. So I don't want to write like this. I want to write it like that. Okay, so n plus 1 over 2. Okay, so you can see that when n plus 1 over 2, I will get this the summation for Sn, which is 1 plus 3 plus 6 plus 10 plus 15 from here. Okay, now look at this. I'm not looking at I here, I'm looking at n term here. Okay, so at the n term here, this is what I get. Okay, n plus 1 over 2. Okay, so for instance, let's say n is 5. So what is S5? So I have 5, 5 plus 1 over 2, which is 6 divided by 2, 6 divided by 3, 15. For n is 5, I get 15. Correct? Okay, so what it means? So how do I know whether the series converge or diverge? So I need to apply the limit and approach infinity n plus 1 over 2. So we know that it gives you infinity. Okay, so what you say the partial sum, the sequence of the partial sums diverges to infinity. Therefore, the infinite series also diverges.